All right, class. As we go into week two, and our opening chapter is over the infrastructure, data centers, and talking about the hardware of things, the software, the networking. We're going to kind of combine this. We're going to talk about what things used to be and then more what they look like today. And so we go into the world of cloud computing. Now, when I first started teaching about cloud and talking about cloud and working with it in my day job, a lot of people didn't understand this, and now more and more people do. So if you feel like I'm talking down to you, please know I'm not. I'm talking to the people that haven't really been exposed to this yet and don't quite understand what it is. And my only goal is that when we're done here is to walk away and we all have the same understanding. And so at a very, very high level, I'm going to describe cloud. Now, to a lot of people, and again, this is a shrinking group, people don't quite understand and they think the cloud is something kind of magical. They think of data centers. I'm going to pop up a picture here. Here's like what an old style data center used to look like with, you know, here's a good one. We got a guy that's tied up with cables. But when we think of a data center, this is what they look like. They were everywhere. They were all over the country, and we all managed our own data centers. And so when people wanted to start getting out of this world, there were cloud service providers like Microsoft, Amazon, Google, Oracle that said, hey, let us take this data center work. We will do the data center work for you. You focus on what makes you special. You focus on what you should be working with your own company. Don't worry about the data center stuff. We have it. So when you think of the cloud, I want to change the definition of it if you don't already have this definition in your mind. Going to the cloud doesn't mean there's magic that takes place. What it means is you're going to a data center. It's just that that data center is managed by somebody else. And so the one we're going to look at here just in this example is Amazon Web Services. They have hundreds and hundreds of data centers throughout the country. They're all within different geographical locations. I think I can't remember how many there are, somewhere in the neighborhood of between 30 and 35 of geographical locations where their data centers are. Within those data centers locations and within those geographical locations, they have availability zones. So there could be 5 to 6 availability zones within each one of those. Here's a little bit of information, might be deeper than you care about, but what we found is if you put a server right next to another server and you hook fiber between them and you run them and you check the latency between the two servers, you can pick this server up and move it about 30 miles away before you ever can notice any kind of latency in the speed of light. So when you are about within 30 miles, it's the same as if that machine was sitting right next to another machine. So that is why we have the availability zones that are about 30 miles from each other. And the good thing about this is it puts it on different power grids. It allows us to know that like if a storm knocked out one, 30 miles is a pretty good you know distance, and so more than likely if it knocks out one, it's not going to knock out the other. And then we have the regions, so like you have regions on one side of the country, regions on the other side of the country, regions on the other side of the world. So we start playing with that, and that's how we can have backup and recovery. We can have disaster recovery. There's lots of things that we can do within that infrastructure. So bringing it back to being simple, I want to explain that when you move to the cloud, what that means is that you are doing work in someone else's data center. So let's rewind a little bit and let's talk about our data centers and what we did. Within the data centers, we had hardware. These were the physical servers, the storage arrays, the network gear, and then we would put software on top of that, including operating systems, middleware, database applications. And then between them, we had the networking. And then, of course, we had our networking within the data center and then outside the data center to our disaster recovery sites, to across the country, all of that. And then we had our architecture, and this is our custom design environments for performance, security, and scalability. So all of these components are how we always run our business. The difference is now, instead of doing this ourselves, most people are making the decision, let's let somebody like Amazon run this for us. Let's let somebody like Microsoft run this for us. Let's let somebody like Google do this. They can focus on that, and we can focus on what's going to make us special and different from our competition. So if you want to look at one of these, you can go to aws.amazon.com. And then I'm going to show you here, there are different ways that you can go in and create these same things that we used to create. So for instance, I used to, if I wanted a server, I would reach out, I would order a server, I would tell them exactly what they wanted. It would take about 6 minutes to put that server together. They would ship it. When it came to my data center, people would pull it off the rack, they would rack it, stack it, put it in the data center, plug it in. From beginning to end, when you ordered a piece of hardware, it would generally take about 6 to 9 months to get that piece of hardware in. And then one more small little thing, we used to also order hardware that we could grow into. But now the beautiful thing about cloud is we're not doing that. We only want to pay for what we need. So we implement hardware to be exactly what we need right now. And then if we need more, we add it later. Now, some of you may know a little bit of the rest of that story. I'm not going into that. I'm not going to talk about auto scaling and how we grow servers. We're not here to talk about that right now. But the point is, now it's all point and click. It's not ordering, racking, and stacking. So if I come here and I look in compute, I can see that there are several different options for me to choose. And so EC2, which is Elastic Cloud Compute with AWS, this is how I put a server out there. Again, there's other things that we're not going to get into right now. And so I mentioned hardware, of course, software. There are lots of different services that we can put out here. Then we also have our storage. We can put our object storage out here. We can put our file system storage on these. Point, click, minutes away. What used to take me 9 months to order and have in my data center, I can point and click and within minutes have it deployed. And then you can start thinking about the other cool things about that. Let's say I have it deployed right here and everything's going great. And then I was like, you know what? I want to open up a shop in Europe. I want to do the same thing I'm doing here, and I can go over there. They call it going global in minutes. You can copy your hardware over, boom, install your software, up and going. Of course, there's lots of legal things and things that you have to deal with in there as well. So where I'm going with this is this chapter is talking about traditional, the way things were, and it also introduced the way things are. So in a cloud world, things just get a whole lot easier and a whole lot cleaner whenever you're trying to implement these things. See if there's anything else in here. I did put these notes. They're in, I just kind of threw this together. You don't need to study this or anything, but if you want it, just grab it, copy it. You can have this. But again, when we enter the notes here are from data centers to cloud, same pillars, new paradigm, hardware, software, network, architecture. But then you move in the cloud, you have your component, your data centers. You have your hardware, software, network, architecture. It's just that it's point and click create, and it is hardware, but some of these things, they don't feel like hardware because it's essentially you're putting your hardware specs on another piece of hardware. And if you want to dig deeper into this, just start searching for hyperscaler, and you can understand exactly how this works. It's how you make one big machine look like a bunch of different small machines. And then there's a whole study of getting into the hyperscaler to understand exactly how it actually works. But essentially, that is cloud. So anyway, some key insights here. Core disciplines of IT haven't really changed. We still have the same architecture, secure, optimized systems. It's just a little bit easier now for us to do that. And then also we can start them up, pay for them while we're using them, shut them down, cease to pay for them. We can throw them away. We can implement more. And then, of course, now you can't have any conversation at all without talking about AI. So now we think about all the things that we've built with cloud, and now we add the artificial intelligence on top of it. We've already had actions that we would take whenever we needed to in certain areas, but now we can use artificial intelligence to help us even make that quicker and faster. I think I'm going to leave it there, but just know that the benefit of cloud not only is now we don't have to own the data center, we can pay somebody else for the data center. We only pay for it when we use it, which is a great step. If you architect it correctly, it is so much cheaper than it used to be. And also, if you think about yourself, if you're a person out here and you have software and you want to develop, before you had to go find somewhere to do that. Now you can put a credit card in and within minutes be paying by the hour for the hardware that you need to deploy whatever it is that you want to do. So anyway, we'll leave it at that. And then please answer the questions that I have down here. And if you have any questions, please don't hesitate to ask. Thank you.